Insert in doubly linked list. Insertion, it's the process of adding a new node to the doubly linked list. So let us see what are the subcases of insertion and how do you insert a new node to a doubly linked list. So this mainly involves updating the pointers of that node as well as those of the surrounding nodes in order to cope up with the new condition. Okay, so let us say you have this doubly linked list. This is your doubly linked list, and this list is having a head pointer. So all the linked list, as we discussed, will have a head pointer which will point to the first node. Each node will have a pointer to the next node, and because this is a doubly linked list, each node will also have a pointer, previous pointer, which will point to the previous node. So this is the speciality of a doubly linked list. And let us say the values are 25, 15 and 34 in this, and let us say I want to add a new value 31. Okay, this is what I want to add. So in all the cases of insertion, same as what we discussed in singly linked list, the first thing you have to see is whether the list is empty. That is, here you have to see the head pointer. If the list is empty, head pointer will be null. It won't be pointing to anything. Whenever you have something in the list, head pointer will be pointing to the first element. You can see that here. But if the head pointer is not pointing to anything, if it is having value null, that means your list is not having anything. The insertion, how do you do insertion in that case? Simply make your head point to the newly formed link. That is the way you do insertion in a null doubly linked list. So if it is an empty list, if it is not having anything, nothing to see for, it's simple to add. You don't have to go for any sub cases. Simply make the head point to this. This is your head. If it is, let's say, empty, null, then you just make your head point to this node. That is done. But in case your list is already having elements like this, there are special cases. First case is addition at the beginning. Second case is addition at the end. And third case is addition at some specific point. So let us see each of these cases, and most importantly, we need to understand how are these different from a singly linked list. Where does a doubly linked list give you advantage, and in what cases does doubly linked list give you a disadvantage? So in data structures lectures, I always told you, you have to be clear on what is the advantage of each particular data structure, so that when you are designing an application, you would know which one to use at which point. Okay, so let us say I have this new value 31 to be added, and I'm going to insert at the beginning. So this is my first case. First case is insertion at the beginning. Okay, beginning. So I'll mark first here, insertion at the beginning. My new value is 31. So always the first step in insertion is to create a new node which is having the value that you want. So here I want the value 31, and I'm creating a new node with the value 31. This is my first step. So keep one thing in mind: whenever you create a new node in order to insert, always keep your next pointer and previous pointer as null. Both these should be null. Then as per the situation, as according to wherever you want to insert, manipulate these pointers accordingly. But initially when you're doing the creation operation, keep both the pointers as null. In singly linked list, if it is a single pointer, keep it as null. Then you change it according to the situation. So here I am having 31. What is it I want to do? I want to make this the new first node. That is, in place of this 25, it should be 31, and 25 should become the second node. This is the situation. So what do? The first thing that I have to do is to set the next pointer of my new node to the current head of the list, because that should be the second node, right? If this is my first node and the present first node should become the second node, then what should I do? I should make the next pointer of this to point to the existing head. So this is the first thing I have to do. So now my next pointer is pointing to the existing head. Next step is important. Because this is a doubly linked list, you have an overhead operation to change the previous pointers as well. So what do you have to do? The previous pointer of the first node, that is 25, was null, but now you have to change it to point to 31, because now 25 is having a previous node because you inserted 31. And the last one, is it still head? No, 31 is still not the first node, because Because how do you identify the first node in a singly linked list? In order to identify, you see what is the head. Whatever node head is pointing to, that is the first node in your linked list. So presently you made the additions in order to add 31, and the last operation is to change the head. Change the head. Head node should point to your newly formed node that is having the value 31. So now your new doubly linked list is altered so that the newly added node is your first node. So this is how you do insertion in the beginning. So this is very similar to what you did in singly linked list. What is the time complexity? Order of 1. Because you're not traversing through the list or anything. It's a constant operation. You can simply add at the beginning. And what is the space complexity? It's also order of 1 because you are not using any extra space other than what you used for creating a new node. That's constant space. So space complexity is constant. So you have constant time and constant space operation. And understand that this particular insertion, doubly linked list, did not give you any advantage, and actually it gave you a disadvantage that you had to do extra operation to adjust the previous pointer. So here doubly linked list is not having any advantage. You should use a singly linked list if this is the operation you want to do for insertion at the beginning. Next case is insertion at the end. Second case is insertion at the end. So let us see how do you insert at the end. So I'm keeping the head back to 25 and I have to make a new value 31 at the end. So 31 should be my new node. I created a new node. Where do I have to keep? I have to keep at the end. Okay, this is where I have to insert. If I have to insert at the end, again, this is very similar to singly linked list. What do I have to do? I have to go to the head. I have to start traversing. I should traverse through the list till the last node. How do you identify the last node? Last node will not have any next pointer. So next pointer will be null for the last node in the list. So I'll search whether next is null. If next is not null, I'll go to the next. So I'll keep traversing through this list till I reach the last node. Now the next is null. I understood this is the last node. What do I do now? Now I have to update the next pointer of the last node to point to my new node, which is 31. So this is how I do insertion. Insertion at the end, okay? And what is an additional operation you have to do? Because this is a doubly linked list, you have to do this additional operation of making the previous pointer also work correctly. So the previous pointer of your newly created node, that should point to the last node, that is 34. Last node means it was the last node. Now you have your new node as the last node. So this is how you do insertion at the end in a doubly linked list. So what is the time and space complexities here? Time complexity, because you have to traverse from the beginning till the end, time complexity is order of n. Okay, you have to travel through all the n nodes. And what is the space complexity? You are not using additional space, so space complexity is order of 1. There is a catch here, an additional point. In our discussions of singly linked list, we are told that if you have an additional tail pointer maintained, that is, if you were always maintaining a tail pointer throughout, a tail pointer which will point to the last node in your list, similar to a head pointer, if this is a special case, that is, if you were maintaining a tail pointer as well, then insertion at the end can be done in order of 1 time. Time is order of 1. The same holds for a doubly linked list as well. If you have a tail pointer, you don't have to traverse through and reach the tail. You directly have a tail pointer. So you make the next pointer of tail point to the new node, and you make the previous pointer of new node point to the tail. So again, this is not an advantage of doubly linked list. If you have a tail pointer, you can do insertion at the end in order of 1 time and order of 1 space, whether it be a singly linked list or a doubly linked list. So till this point, doubly linked list is having a slight disadvantage of additional operation of adjusting the previous pointer and not having any advantage over singly linked list. Okay, let's go to the third case. So what is your third case? Third case is insertion at a specific position. Let us say I want to insert at some specific position. In this case, how does it work for a doubly linked list? First thing, as always, you create a new node with value 31. I created a new node. New node is having value 31. Next step is to identify the position at which I want to insert. Let us say I want to insert at position number 3. Position number 3 is where I want to insert. So this is position number 1, 2, 3. So instead of 34, my new node 31 should come at 3 and 34 should go to 4th position. That is what I want. So in this case, during singly linked list, what did we discuss? Whenever you want to insert, you should only traverse one step behind that. That is, you should stop at index 2 if you want to insert at index 3. The same is the case with doubly linked list as well. Because you want to insert at position number 3, you should stop your traversal from head at position number 2. But because this is a doubly linked list, there is no danger that if you have a point, if you directly reach number 3, you still can go back and see what is number 2. So you have a previous pointer, because of which you have the flexibility of going back and forth. But anyway, you are traversing from starting, so only traverse till one step behind. Okay. So once you reach one step behind, from this point, what do you know now? You want this node with value 31 to be here. That is between 15 and 34, you want 31 to be inserted. So how do you do this? The first step is to always, when you are manipulating a doubly linked list, in case of insertion, always make sure that you manipulate the next and previous pointers of the newly created node first, because that will make sure that you don't miss out the links to the next and previous pointer, previous node. So because you want to insert this 31 here, you want to insert the value 31. What should you do? You should first modify the next and previous pointers of 31. The next pointer of 31, it should be made to point to the node which should be the at next to 31, that is presently at index 3, that is 34. You should make next point to this and previous point to this. Okay, this is your first operation. What did you do? You made the next point to the succeeding node and you made the previous pointer of your new node point to the previous node, preceding node. So with this step, you are making sure that you establish the connections of the new node and you don't lose out on the connections that you already have with this list. What is the next thing? You have to modify the pointers of 15 and 34. How do you do that? You have to make the next of 54 should point to 31. That is the first step. And the previous of 34 should point to 31. So this is how you recreate or insert a new element in the linked list. So only thing you have to be careful is, in order to be on the safer side, always manipulate the next and previous pointer of the new node first. Because what will happen otherwise? See, because this is a doubly linked list, still you have some way of going back and forth. But the problem is, when you write the program, you might be accessing this node through this node or maybe through this node. So according to the way you're writing the program, it may hinder your chances. That is, you may refer to a wrong node if you don't manipulate the pointers of the new node first. You have to be careful while you're writing the program. I'll show you where. For example, if what you did is you had this pointing here and a previous pointer pointing here. Let us say I updated the next pointer of 15 to point to this. Okay, I updated this. And let us say I was standing at position number 15. Okay, and how was I accessing 34? By doing 15 pointing next. So if I look at the next pointer, I was able to access 34. But what did I do? I first removed this next pointer. I made it to point to the new node. The problem now is, because I'm standing here, I'm standing at 15. I no way can reach 34 now, because the only link to 34 was the next pointer of 15, which I removed in order to mark it to 31. Now I have to do a lot of operations with 34. I have to make a next pointer here. I have to make a previous pointer to point to 31. These operations I can't do because presently I am standing at 15 and I don't know what is the path to reach to 34. But if I had kept this pointer intact, if I had kept this next pointer intact and I had modified the pointers of 31, let us say I made this to point to this and its previous to point to this. Now, if I want to reach from 54 to 34, I can do that. And this is my new node. I always have a pointer to the new node with me. So I have two ways of reaching 34. One is from 31 I can do next, or from 15 I can do next. Then I can change this next pointer safely to point to 31. I can safely change this previous pointer to point to 31. So the safer side is always if you change the pointers of newly created node first and then manipulate the other nodes. Okay. And so what is the time and space complexity here? The time complexity, because you have to traverse through the list, till the point you reach the point of insertion, time complexity is order of n, and space complexity is order of 1 because you are using constant space. The only spaces for building the new node. Other than that, you are not using any extra space. Let us see one special case here. One thing is, if you want to insert at in place of some value, that is presently I told I have to insert at index 3. That is the case. Instead, if I am saying that I have to insert next to some value, let us say some value 15 or some value 34, in that case I have to first use the search algorithm. I have to search for that point. I have to reach till one point behind, then I have to insert. And because this is a doubly linked list, even if you reach till that node, you can go back and see what is the node just behind. So that's not an issue. So this is about insertion. And one special case I have to discuss here, that is a case in which doubly linked list will have an advantage. That only case is if I am saying that this is my previous linked list, if I am telling you that I have a pointer to 34. I'm giving you a pointer to 34 and I'm telling you the insertion that I want to do is before this list, this node. That is, I'm giving you a pointer to a node and I'm telling you I want to insert before this. That is, here I want to insert. In this case, this is the only case where doubly linked list will have an advantage of insertion over singly linked list, because if it is a singly linked list, if I'm giving you pointer to 34, you have no way of inserting something new before 34. That is, between 15 and 34, you can't insert in a singly linked list because you don't have the previous pointer. You again have to start from head and traverse till here, reach 15 and then do the addition here. But because this is a doubly linked list, you have an option of going back through the previous pointer to the previous one and then doing an insertion between 15 and 34. So in this is the only case, that is, if you're given a pointer and asked to insert before that, that's the only case where doubly linked list can do in order of 1 and singly linked list will take order of n. So this is the only point where doubly linked list will have an advantage in case of insertion.